Good afternoon, students. It is a very, very cold Tuesday, January 21st. Hope that we had a nice fake snow day. I have a silly joke. I don't know if I've done this one before, but this is funny to me, like big time. Okay. Do you know what seems odd to me? Numbers that can't be divided by two. Because they're even. And they're odd. So that's funny. Okay. Oh no, that's tomorrow's. Okay. All right. Oops, that's not what I mean to do, but yes, that is me and Cookie Monster a while ago. Okay. Now we have been working on rounding. We have been working on decimal placement. We have been working on we're about to start working on adding decimals, and this entire unit 5, is all about that. Okay, so here we go. We're rounding decimals to the nearest whole, tenth, and hundredth, paying attention only to the ones right behind it. So for the tenth, sorry, this one, and then we would circle this one, and then for the hundredth it's this one, and circle that one, and everything before stays the same. Everything after gets zeroed out. All right, let me see if I can make this a little bit bigger. All right. So Samuel marks a point on the number line below as shown. Okay. And he is in between 3 holes and 2/10 and 3 holes and 3/10. So that means that each one of these are hundredths. So each of them are 3 and 2/10, but this is 100th, 200th, 300th, and then this would be 400th. Okay. Having that understanding of the number line is absolutely essential. All right. So I don't know, it's a little bit fuzzy. All right. I'm trying. Okay. All right. One more time. All right. Okay. According to the number line, what's a reasonable estimate? Well, first, it has to be 3. So that's good. Second, it has to be 2/10, which is that good. But then it can't be, let's see. Well, 3 and 2, 4, 2400 too far. Let's see. 3 and 2/10. Looks like it's 3 and 2/10. So that's good. Let's see if it's the third hundredth. 100th, 200th. Yep. Third hundredths, right? Fourth was too far. And now, is it closer to the 300ths or to the 400ths? I'm thinking it's not on the hundredths. So it's closer, it's in between. So we have tenths. This is a tenth. And then in between the tenths, the next tenth, are 10 hundredths. And these are all hundredths. So just like, we count 1, 2, 3, 4, 5, 6, 7, 8, 9. There's ones. As soon as we hit 10, we have 1/10. As soon as we have 10 hundredths, we have 1/10, right? Those are equivalent. All right. Let's see, what is 865 thousandths rounded to the nearest hundredth? So I'm going to underline hundredths because that's my target place value. All right. And then in my target place value, I'm going to look to the right to the thousandths place. And it looks like I have 86 hundredths and 1,000ths here, 86 hundredths and 2,000ths, 86 hundredths and 3,000ths, 4,000ths, 86 hundredths, 4, 86 hundredths and 5. Okay. And this would be 865 thousandths. And when it is half or more, we raise the score. And so we have now moved it to 87 hundredths because 865 thousandths is closer to, well, at that halfway mark, we round it up. Okay. So this rounds, I'm going to write 865 thousandths rounds to 87 hundredths. And that's the target number I wanted, target place value. Okay, next one. Pay attention to the space here. Okay, it takes 686 and 9,800 days for Mars to revolve around the sun. Oh, that's wild. So like here's the sun and here's like Earth. And then here's Mars. Mars, not the candy bar, this is Earth. Okay. What is this number rounded to the nearest whole number? Okay. So I have 686.9. I don't care what's in the hundreds place. I'm only interested in what's in the tenths place because that's the next smallest number. And this is almost to the next whole number. So this is going to bump up to 7. And that should be the last, like this should be eliminated immediately because it's not to the nearest whole number. Okay. And then it did bump up. So that's great. All right, number 4. The flagpole in front of the local post office measures 23 and 438 thousandths feet tall. What's the height rounded to the nearest 10? All right, so I have 23 and 43 hundredths. Doesn't matter what's in the thousands. It only matters what's in the hundredths here because I'm rounding to the tenths place. And I have 3, which means that I'm only 3 tick marks away from 4/10. It's not enough to bump it up. And so I would cross that out immediately because it doesn't even have tenths place, and cross that off because it's hundredths place. And so it was in between 4/10 and 5/10, closer to 4/10. Sweet. All right. Now I'm going to circle all the decimals below that when rounded to the nearest tenth, round to 4 and 9/10. All right. So I'm going to underline my tenths and circle my hundredths. Okay. So I can treat them all the same. Okay, and I cross that off because I don't need the thousands for that. All right, so this is 4 and 8/10, and then 4 hundredths. Nope, not enough. 4 and 9/10, but 7. Nope, too far. This one works. Is that number? 4 and 8/10, and then 6 hundredths on my way to the next tenth, which would be 4 and 9/10. 4 and 8/10, 2 hundredths, too close to 8/10. 4 and 8/10. 5 hundredths on my way to the next hundredth, and then 4 and 9/10, 4 and 9/10, excuse me, 4 and 9/10, and then 4 hundredths stays at 9/10. So we have those 4 numbers. All right. Okay. All right. What is 340 and so that's 340 and 19 thousandths. So first of all, I'm out to the thousands place. This is where the 19 goes because it has to end there if I'm saying this out loud. And then I'm looking for it. Boom. I'm not going to get tricked by that hundredths place. All right. And then what's the value of the digit 7? That's in the thousands place. Ones, tenths, hundredths, thousands. Okay. On Friday, and just in general, we want to be able to order decimals. So ordering decimals means lining up the numbers and adding a 0 in any placeholders that you need to. And then you compare each place value. So the minute you see that these are zeros, and then we're ordering from least to greatest, not always, but in this case, yes. Okay. We are ordering, so these are smaller, and then I go to this one. So this is the smallest. When they say for least to greatest, that is also in ascending order. Okay. Greatest to least is descending order. Okay. Ascend means go up. Descend means go down. So that's why it would be greatest to least. Okay. So let's check this out. We're going to use greater than, and I'm going to write it here. So I have enough. This is greater than. And this is less than. Kind of looks like an L. All right. So let's check out my numbers. I don't know why this is so like not clear. It's a brand new computer. Try one more time. All right. Well, here we go. All right. So I have tens, ones, tenths, hundredths. Ooh, and I have an extra thousand. So let's make that a little bit bigger. This is 92 hundredths, which is bigger than 92 thousandths, right? This is 8 and 14 thousandths, 8 and 14 thousandths. So that is less than 15 thousandths. Okay. Okay. Hundreds, tens, ones, tenth is bigger. 3 and 7/10 and 37 hundredths. Sometimes I have to write it down, right? To know. And then if I have 105, oh no, 5 and 2 thousandths. Let's figure this out. 100, 50, and 2 thousandths. Oops, that one's bigger. 150. Now I have 8, 8, 6, 6, equal. Great. Okay. All right. Now let's arrange the numbers from greatest to least. And this is what we call descending order. These words will come up a lot. Okay, so greatest to least. So I'm like lining them up by the decimal. 7.308, 7.38, 7.3, 7.038. And I'm filling in the zeros just so, you know. Okay. Now I want the largest number. So they all have sevens. And then actually, I also can go like the smallest number, which I know is here. So I'm going to do 7 and 38 thousandths. It's the smallest number. Then I have 4 numbers. So I'm going to put 4 spots. I like to just kind of organize my space ahead of time. Then I see that these all have 3. And then, ooh, that one has 8 here, which actually makes that one the biggest. And then I'm here, ooh, and this one has 0. That one has 0, but there's 308 thousandths. And then this is just 300 thousandths or 3/10. So we could have this here. That is not a problem. Those are equivalent amounts, right? All the way out to the thousands place. And then those are equivalent. It is customary to write it in the like original form. So I would, you know, if you can write it in the original form, I definitely would. All right. And again, we want them from greatest to least. 1, 2, 3, 4. I have 182, 205, 180.25. I already kind of see a difference. 182.251 and 180.215. Okay. So I have 280s and 282s. Let's look at those first. 182 and 251 and 182 and 205, 182 and 251 is the biggest. 182 and 205 is next because it has 2 holes over the other ones. All right, now I'm just looking at 2500s and technically just 2100s, which makes it smaller. Even though it has an extra digit, doesn't matter. There was a 5 in the hundredths place. Okay. So this is largest to smallest. Descending. I'm going down to a smaller number. Now I want least to greatest. That is ascending. Ascending. And then descending is down. D for down. D for descending. All right. So again, I am listing the numbers each time, even though I am like your teacher, I'm still ordering them. That's just how our brains work. When we try to look at numbers like sideways, it just doesn't work. Okay, so if I'm going ascending, I'm starting with the smallest number, and that's going to be 1 and 853 thousandths. 1, 2, 3, 4. Cross that off, and then I have 18. And then look, I have 0/10. So that has to go next because again, I'm going from least to greatest. And then I have 3/10, 18 and 38 hundredths. And then I have 5/10, which makes that one the biggest. All right. So that worked out nicely. All right. Now, which inequality is true? Which means that, remember, this is greater than, and this is less than. All right, so this is saying 5 and 271 thousandths. Is that more? Yes, so far that's true. And then is this? No, because 3/10 is bigger. 3/10 bigger than 21. No, because 27 hundredths is bigger than 21 hundredths. 5 and 2/10. No, 3/10. So it has to be this one. 3/10 is bigger. 7/10 is bigger. It is D as in dog. Okay. All right, and then our last one. This is actually, I think, a really cool part of the work. The following table shows distance traveled by a paper airplane during a contest. Use the information from the table to determine whose paper airplane flew the furthest and came in first, second, and finally third. And these are in meters. So let's take a look at first, second, and third place. If it's distance, I want the largest. If it was time, I would want the smallest. So here I go. Largest amount, 4 meters, 5/10. Ooh, 4 hundredths. Michael. Michael with 4 and 542 thousandths meters. And then, so this is first. And then Patricia, 4 and 54 hundredths, because that would be 0 thousandths. And then Sabrina, 4 and 524 thousandths. All right. Well, we have ordered, we have rounded. Hopefully, we are practicing, and I'll see you tomorrow. Bye bye.